Good afternoon, everyone. I'm a PhD student from Zhejiang University. It's my honor to be here to share my research about the impact of urban form on building energy consumption. Okay, let's start. In recent years, the building energy consumption of China has been increasing rapidly due to the urbanization, which poses huge challenges to building energy conservation, especially for the residential buildings. Numerous studies have shown that the building energy use can be reduced by 10 to 30% through urban form management. There are two main reasons. In this study, we identified that the urban form had two effects on building energy consumption. Firstly, the interbuilding shading effect, such as blocking the solar radiation, can alternate the building energy consumption directly. Secondly, the urban form affects the urban climate, such as urban heat island effect, and thus alters the building energy consumption. However, the impact mechanism of urban form on building energy use, including direct and indirect influence, have been lacking in quantitative research, particularly in different building climate zones. China's climate zones have considerable impact on building energy demand, especially for space heating and cooling. Therefore, the direct and indirect influence on annual building energy consumption and require a case-by-case analysis based on specific climate background. Building codes and construction choices need to address thermal loads to reduce energy demand for space conditioning as least. Weather data are key information for building energy simulation. The available weather data are usually observed by weather stations in the rural area or airports, which cannot represent the urban heat island effect. In this study, the weather data in urban area was provided with the urban weather generator, with the input of rural weather data and urban parameters. As shown in this figure, the temporal variation of urban temperature is captured well by the UWG model. To be clear and concise, only the data in July is presented here. Next, to validate applicability of the building energy simulation method, we developed a building model in Design Builder based on the urban weather data, and it was validated with the measured building energy use data. Here as references in the study cases, as a baseline scenario, there is no interbuilding shading effect or urban heat island effect in isolated building. In contrast, the microclimate of urban form is clearly affected by surrounding buildings. Thus, when simulating the center buildings, both direct and indirect influence should be considered. 9 cases of urban form are designed to consider the different building air densities and building height. Here are the results. As the finger shows, it shows the daily change of average outdoor temperature in the hottest months and the coolest months of 9 cases. In general, rural temperature is lower than the urban one, apart from minor variations. The peaks of urban heat island effect occur in the early morning and nighttime, and it was worth noting that the compact high-rise building exhibited the hottest, while the temperature in rural is lower. As well as the air temperature, various urban forms differs in the reception of solar radiation through windows. The maximum difference of it can up to 64% between isolated building and compact high-rise building. Furthermore, we made a quantitative of cooling demand in the hottest months. As you can see, for the 5 building climate zones, the direct influence can mitigate the negative impact of urban heat island on the increased cooling load. From an annual perspective, its figure shows a trend in winter and summer in the heat. It shows that the urban heat island intensity is positively correlated with the building density and building height. Finally, 60 cases are simulated to calculate the annual cooling and heating demand of 9 urban forms from Region 1 to Region 2 compared to the base cases. Results show that the space cooling and heating energy use of buildings in grid exhibited large differences when the building morphology and climate or city changes. as they demonstrate both positive and negative impacts on the annual cooling and heating demand. Based on the results, we can find some regulations, and these findings provide some guidance for the urban planning in different climate zones. Thank you, and this is my initial exploration of my urban microclimate and the urban form. Thank you very much.